In this video, I will walk you through free response question number 3 from the 2014 AP Calculus exam. This problem is primarily about integral defined function g, which is based on the graph of function f. The function f is defined on the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of x equals the integral from -3 to x of f of t dt. Part A, find g at 3. Well, g at 3 just means we will plug in 3 for x and evaluate. So we have the integral from -3 to +3 of f of t dt. This definite integral represents the area between the curve and the x-axis from -3 to +3. The yellow triangle has an area of 10. It is considered positive because it is above the x-axis. The blue triangle has an area of 1, but it is considered negative because it is below the x-axis. So we have g at 3 is equal to 10 minus 1. In other words, g at 3 is equal to 9. So that's it for part A. Part B. On what open intervals contained in the interval between -5 and 4 is the graph of g both increasing and concave down? Give a reason for your answer. For this problem, we will use the common case of the second fundamental theorem of calculus. The common case is where you have an integral defined function where the lower limit is a constant and the upper limit is just x. In that case, g prime will equal f of x. This integral defined function does fit the common case, so g prime equals f of x. We are looking for intervals where g is increasing. First semester we learned that g will be increasing when g prime is positive. So if we want an interval where g is increasing, we will look for an interval where g prime, which equals f, is positive. It's important to write it this way, g prime, which equals f. We always must refer to the graph that we are given. We are also looking for an interval where g is concave down. First semester we learned that g will be concave down when g prime is decreasing. So we are looking for an interval where g prime, which equals f, is decreasing. In other words, where is g prime, which equals f, positive and decreasing? This is the graph of f, which equals g prime. We can see that it is both positive and decreasing in 2 intervals, from -5 to -3 and from 0 to 2. Function g is both increasing and concave down on the intervals from -5 to -3 and from 0 to 2 because g prime, which equals f, is positive and decreasing. Again, it's essential to state g prime, which equals f, because f is the graph that we are given. Part C. The function h is defined by h of x equals g of x divided by 5x. Find h prime at 3. To find h prime, we will need to use the quotient rule, which goes low d high less high d low. Draw the line, and down below, the bottom squared will go. What was that? What do you say? Low d high. Low means write down 5x. D high means the derivative of the top. So that's going to be g prime of x. So that's low d high less high d low. High means just write down the top. And then d low means the derivative of the bottom. So that's 5. So right now we have low d high less high d low. Draw the line, and down below, the bottom squared will go. The bottom squared is just 25x squared. Remember, g prime is equal to f of x. So on the next step, I'm going to swap that out. Kabam! Next, I'm noticing that both terms have a 5 in it. So I'm going to factor out that GCF to make it easier to simplify. So now we have this, but 5 divides evenly into 25 5 times. This is my simplified expression for h prime of x. We were asked to find h prime at 3. So I will simply substitute 3 for all of the x's. So now we have this. Let's use the graph of f to find the value of f at 3. We find that f at 3 is equal to -2. So on the next step, we will make that substitution. What about the value of g at 3? In part A, we found that g at 3 is equal to 9. So right there, this is an acceptable answer for a free response question. Or we can put that h prime at 3 is equal to -1/3. Part D, the function p is defined by p of x equals f at x squared minus x. Find the slope of the line tangent to the graph of p at the point where x is equal to -1. Saying the slope of the tangent line is a long way of saying the derivative. So let's find p prime of x. We are going to have to use the chain rule. So we start by taking the derivative of the outer function. So I will write f prime of x squared minus x. But then we multiply by the derivative of the inner function. So I'm going to multiply by 2x minus 1. We are asked to find the slope of the tangent line where x is equal to -1. So we need to evaluate p prime at -1. So here I have substituted -1 for all of the x's in the p prime of x expression. -1 squared is 1, and then we have 1 plus 1. So we have f prime at 2 times -2 minus 1, which is -3. To evaluate f prime at 2, we need the slope of f at 2. This is the graph of f, and here is f at 2. What is the slope in this interval? Well, it seems to be down 2 over 1, down 2 over 1. So this slope is -2. So we end up with -2 times -3. In other words, p prime at -1 is equal to 6. So that's it. The slope of the tangent line at x equals -1 is 6.